Good morning. Thank you, Michał. It's a great pleasure to be here. Thank you for making me so welcome. I want to talk to you today about solving the innovation equation. Innovation has never been more important, and it is getting more important every day. Why? Because we live in an increasingly uncertain world. The pace of change is increasing. Does it feel like that to you? The only way for businesses to thrive in an environment like this is to change and adapt their products, services, and processes. We need to change quickly, and innovation is how we do that. But how do we make innovation happen in our businesses? How do we encourage it? How do we make it routine? How do we write innovation into the DNA of our organizations? I want to start by asking you a question. What is the one thing that you would improve about your innovation process if you could? Anyone want to make a suggestion? Savings. Okay. Reduce cost. Yeah, make it cheaper. Anything else?
Speed of innovation.
Speed. Make it faster. Absolutely. Make it easier. All the good, simple words. That's really good. Thank you. But actually, improving innovation is not easy. And the reason is because innovation is a paradox. Innovation is a contradiction. For example, businesses want to innovate to stay ahead of the competition. But at the same time, they don't want to change anything because change is risky and expensive and it's slow and all the things that we don't want about innovation. Perry Smith et al., in their study of the innovation process, observed that innovation is a rare and difficult occurrence. Is that your experience? My whole career really has been about innovation in one form or another. Whether, as an undergraduate apprentice right through to senior manager. And so it's my privilege to share with you today some of the lessons and observations that I've made in that time. And so what I want to do today is really try and build a picture of what innovation is, what its key elements are, how we can put those together to make a whole picture. So I want to introduce you to a change equation and an innovation equation and show how we can put these together to build the whole picture. And that picture will then help us to see where we can improve our innovation process and how we can go about improving it. But first, let me explain where I'm coming from on all this. These are observations, these are lessons from my 39 years working at Rolls Royce, who make gas turbines and other power systems, by the way. They don't make cars. So really from undergraduate apprentice, design engineer, inventor, innovation leader, and manager of research and technology, I've really been involved with innovation. And I want to, as I say, share with you those lessons. So in building a picture, I'm not going to talk about an innovation process. Lots of people look at innovation from that perspective, which is great. But I want to really look at what the key elements of innovation are. What is it? What are the ingredients that make innovation happen? And so I want to introduce you to an innovation equation. Now, you will find a number of innovation equations on the internet. They all have value. Even James Dyson has one. But if I ask you, first of all, what do you think the key elements of innovation are? What would you suggest? People? Innovation does not happen without people. Very good. Yeah. Anything else?
Technology.
Technology? Yes. Imagination.
Open mind of those people.
Open mind of those people.
Curiosity.
Sorry?
Curiosity.
Curiosity. Yes. Very good. Yeah. All of this, somewhere or other, comes into helping us to innovate. Now, if we define innovation as the generation and implementation of new ideas, then this is my innovation equation. Innovation equals creativity times knowledge times project management. Now, I'll talk about each part of this in more detail, but what I want to point out first of all is that this is a multiplying relationship. Okay, so it doesn't matter how much creativity and knowledge you have. If you have no project management capability, your innovation is probably going to be zero. And it also means that your ability to innovate is going to be limited by your weakest link, whether it is creativity, knowledge, or project management. Now, let's move on to creativity. Creativity is universally seen as essential to innovation. Imagination is part of that. If we look at all the innovation equations, they make creativity explicit. And most problem-solving tools and process improvement tools will sooner or later have a step that says generate ideas or something like that. But most don't help you do that. Of course, there are techniques around to help you. But even so, creativity can seem hard to turn on when you really need it. Which begs the question, does creativity have to be so random and disorganized? And then the other common observation is that some people just seem more naturally creative than others. Which also begs the question, are we stuck with the level of creativity that we have? Well, I've come to the conclusion that the answer to both of these is no. I've had an interest in creativity and innovation for a long time. 23 years ago, now, I went to a lecture at Loughborough University in the UK called The Theory of Inventive Problem Solving. The speaker was a Russian. He had a thick accent. But the more he talked, the more excited I became. What he was saying about how to generate innovative solutions just seemed so powerful and yet so simple to me. I was leading a design team at the time, and we were grappling with an advanced engineering problem. It was a problem caused by centrifugal force. You have a lot of centrifugal force in a gas turbine. And so I went back to the team the next day and said, I went to this lecture last night by a Russian guy, and he said, when we're solving a problem, we should try to use the thing that's causing us the problem to solve the problem. So we sat down and we generated some ideas about how we could use centrifugal force to solve the problem of centrifugal force. We hadn't done that before. We generated an interesting idea, we worked up the design, we tested it, and we filed a patent. So that was it really. I was pretty sold on this theory of inventive problem solving thing from that point. Sometime later, when I was in a role responsible for improving the design process in Rolls Royce, I was keen to investigate this methodology further. And I finished up championing it within Rolls Royce for over 10 years. What's this methodology called? It's called TRIZ. TRIZ comes from the Russian for theory of inventive problem solving. TRIZ was developed in Russia over 50 years. It involved the analysis of over 2 million patents. And as far as I'm aware, it's the biggest study into creativity and invention ever, estimated to have taken 1,500 person years worth of effort. Oxford Creativity helped us introduce TRIZ to Rolls-Royce. And since leaving Rolls-Royce, I've been working with Oxford Creativity, facilitating customers in problem-solving workshops, providing training, and there's something very, very exciting and satisfying about helping clients come up with innovative solutions to real problems. So I really enjoy what I'm doing. But how does TRIZ work? Well, TRIZ is really a distillation of the world's knowledge about how to generate breakthrough solutions. It's got a number of tools, and the first one is really a philosophy. It's a philosophy that says the strongest solutions, the best solutions, are the ones that minimize the introduction of new resources into your system by maximizing the use of what you already have. Even harmful and waste things, like centrifugal force. This is how you create really elegant solutions. I really like this about TRIZ because it's this philosophy at the heart of TRIZ that really helps generate simple and low-cost solutions to problems. And we really need that. We need it fast and we need it cheap, as we were saying. Because in my experience, it's relatively easy to come up with a complicated solution to a problem. The paradox is that keeping things simple is not easy. Mm-hmm. The Russians were very good at this. So I remember one example where they had a molten vat of metal that they needed to transport, and they needed to cover it, insulate it. So the standard solution would have been to put a heavy, complicated lid on this. But the Russians came up with a way of using the thing that was causing the problem, the molten metal, to solve the problem. How? They sprayed water onto the surface. It made the molten metal form a slag, which was a good insulator. Problem solved. Another really powerful tool in TRIZ is the 40 inventive principles. Now, it blew my mind when I first came across this to think that as all the problems I could face as an engineer can be solved by applying one of 40 principles. Someone has gone to the trouble of defining this and writing it down. And if 40 still seems like a large number to you, then there are ways in TRIZ for suggesting much smaller numbers to look at first. Another tool in TRIZ is the 8 trends of technical evolution. So the research showed that technology and systems evolve along predictable trends. We used this recently with a client who wanted to predict how their product would evolve in the future because they wanted to look at ways of prolonging its life. Another tool is the 76 standard solutions. What I like about this is, although it's a longer list, it does provide you with a systematic way of addressing functional problems within your system. And Oxford Creativity have broken this down into sub-lists to help deal with harmful effects in your system or insufficient effects or measurement and detection functions that you need. And another tool in TRIZ is the TRIZ effects database. This really is a distillation of the world's scientific knowledge. It's like problem solving with Einstein, basically. And so we had a client recently who needed to find a way to increase temperature in a very constrained system. So let me ask you, how many ways do you think, how many distinct ways do you think there are to increase temperature? Any suggestions?
120.
100? 20? 2, okay. A wide range. Well, in the effects database, it gives you 129 different scientific effects, physical effects, that you can use to increase temperature. This is a free resource available from triz.co.uk. And as I say, it's like problem solving with Einstein. Now, one of the simplest tools and really powerful tools is the 14 Venture Principles. And I have a favorite principle, I have to confess, and it is principle number 13, the other way round. Now, this principle says whatever you are doing now, think about doing the opposite. If you are heating it, try cooling it. If you're moving it, try keeping it still. We were grappling with a software problem in Rolls Royce. We were trying to automatically calculate a complex aerodynamic parameter. But the software kept falling over as the geometry changed. And the team worked for months to try and make this work. Eventually they said, we need to find a different approach. They had been TRIZ trained, and so they sat down with the 14 Venture Principles, and when it came to principle number 13, they said, okay, what are we doing now? We are creating a CAD solid model of the metal. What would the opposite be? Well, maybe we could create a solid model of the air instead. So they tried that because they thought we'd have never thought of doing that. It solved the problem overnight. So, examples like this and personal conviction based on experience is one thing. But does TRIZ stand up to scientific scrutiny? And what are the long-term as well as short-term effects of being trained in TRIZ? I wanted to know the answer to this, so I commissioned some research. And I'm very grateful to Kamal Birdi et al. For producing this paper in R&D management, where they reported a longitudinal study over 3 years, where they studied engineers who had been TRIZ trained and compared them with engineers who had not been TRIZ trained. What they found was very interesting. They found there were short-term improvements in both the creative problem-solving skills and motivation. They found longer-term improvements as well in their idea suggestion. And they found that they were improving their creative problem-solving skills and motivation, and also idea generation and implementation. I was very pleased with this, and after championing TRIZ for over 10 years, I was more than a little relieved. I could tell you that there was a real basis and real evidence to say we'd been making a wise investment. Their findings said there was strong evidence for increasing creative capability and motivation. They found also the evidence for more ideas being implemented was variable, which I think is a very fair result, because creativity is important to innovation, but there's a lot more to innovation than just generating ideas, which is why there's more to the innovation equation than just creativity. Knowledge is the second variable in the innovation equation. Knowledge is vital to any business process. We need knowledge to know the right questions to ask, let alone the right problems to solve. You need knowledge to evaluate your ideas, improve them. But knowledge can also trap you in psychological inertia. You can get to the place where experts can get very good at telling you why something can't be done. But history shows us, the amazing things that can be done by people who don't know that it can't be done. Many people knew that heavier than air flight was impossible. Fortunately, the Wright brothers did not know that. But the other thing about knowledge is that we need to learn. We need to know how to learn. And there's an interesting phenomenon that's fascinated me for some time, called learning curve. Learning curve was first discovered in the 1930s when they were studying how the cost of airframes reduced as they increased the number that they made. What they found was every time they doubled the number that they'd made, the cost came down by a fixed percentage. Now, this phenomenon has been studied very widely since. It's been found to follow an inverse power law, like this. And it's been found to not just apply to cost, but other product attributes as well. And technology capability improves along a trend like this. But learning curve poses a very interesting question. Can we learn faster? Because if we can learn faster, then we can innovate faster. So the exponent in the equation is the learning rate. And the graph here shows if you double your learning rate, then you improve at twice. You improve twice as fast, even though you start at the same place. There's a very interesting paper by McNerney et al., where they modelled learning curve effects in complex systems. And what they found was that there are two ways to improve learning rate. The first is fairly obvious, and it's to make it easier to improve the components in your system. But even to improve a component, you need to have knowledge. You need to understand that component. You need to know how it fits into the system as a whole. Have you ever seen someone designing a component like the last one without really understanding why the last one was designed the way it was? You can only do that for so long before it catches you out. But the second and more perhaps unexpected way to increase learning curve is to simplify your system. This is why simplifying product architectures is important, and why modularity is so powerful. Rolls Royce discovered the power of modularity by accident 50 years ago, when some fitters found by accident that they could remove the whole external pipework off an engine by just undoing a few bolts. And Rolls Royce has built modularity into all its gas turbines ever since. But there's another question that learning curve poses. Learning means change. And all change must be good, right? Well, according to Learning Curve, no. Not all change is good. Learning curves imply that stability is desirable and that instability can be very expensive. This implies that, the best team to design a new version of your product is probably the team that designed the last one, because they will have the learning already in their heads. Organizational change, process change can disrupt learning curves. And it's part of the hidden cost of organizational change if we change things without being aware of what learning there is and how we protect the learning curves that already exist. I sort of experienced this in a positive way on one engine program. I was leading the team designing the fan rotor on an engine, and it was quickly followed by another engine, and so I was able to use the same team to design that fan rotor as well. They had all that learning in their heads, and so that second design, we designed it faster, it was fundamentally lighter and cheaper and better due to the benefit of learning curve. Have you ever experienced change fatigue? Do your teams ever complain to you about change? Thank you. They may not be aware of it, but I think part of change fatigue is that change can disrupt learning curves. That they might express it something like, I've only just worked out what I'm supposed to be doing and you want to change it again? And this is part of the paradox, again, of innovation. How can we improve our organizations and processes if we don't change them? But if we change them, we run the risk of disrupting learning curves. And that means you won't get the benefit you would have done if you'd have left things alone. So, we need to change, of course, yes. But we need to try and find ways of changing that minimize the disruption to learning curves. I hope you'll be aware of that next time you want to change something. Okay. So the third variable in the innovation equation is project management. Now, this might be a surprise to some of you. It's not very often that you see innovation and project management in the same sentence. But in my experience, project management is absolutely vital for any innovation of any significant complexity. I finished my career managing a team of global project and program managers, and I developed a healthy respect for a good project manager who can make things happen. But I'm an engineer, and to most engineers, project managers are like a curse from God, leave me alone. But the implementation part of innovation needs people who can make things happen. And project managers, good project managers, are people that can make things happen. So, what do I mean by project management in the context of innovation? Well, here are 7 key factors around project management and innovation that I think are important. Does anyone want to suggest which one of those they think is maybe the most important?
You mean for the project managers or for us?
For innovation. Yeah, for innovation.
Maybe the leading and motivating the team.
Leading and motivating the team, yeah. That, of course, is very important. They're all important. Actually, from my perspective, I think the most important is maintaining good communication with all the stakeholders from beginning to end of the innovation. In 2002, two colleagues of mine and I, we presented a paper which looked at the technology transfer process and how that worked in Rolls Royce and the benefits. And what we presented was a model which showed two key elements of technology transfer, assimilation and acceptance. Now, assimilation is the sort of mechanical elements of bringing technology into a business, integrating it into systems and processes, that kind of thing. But actually the more important and more difficult part is acceptance. Acceptance is about winning the hearts and minds of key stakeholders in your organization. And acceptance has some critical success factors. Which one do you think is maybe the most powerful one?
Second.
The second? Building open and trusting working relationships. Yeah, really important. Actually, we did an analysis where we looked at the business benefit from research, which was considerable, by the way. And what we found was the statistically most significant factor was not things like the amount of research funding that was put into a project. The statistically most significant factor that generated the most business benefit was frequent informal interaction between the researchers and the people who were going to use their research. You know, it turned out that technology transfer, like a lot of innovation, is more about people than anything else. Okay, so we've looked at an innovation equation, and now I want to introduce you to a change equation. Sorry for all the equations, I'm an engineer, I can't help it. Okay. We know that change is essential to innovation. But if we look at what that looks like as a change equation, then like the innovation equation, my change equation has three variables: capability, motivation, and opportunity. And like the innovation equation, this is a multiplying relationship. It doesn't matter, again, how much capability you have or opportunity to do something. If you've got no motivation, the benefit from your change is likely to be zero. You know, have you ever wanted to do more exercise? You know, what stops you going to the gym? Is it capability? Perhaps you don't know how to work the exercise machine. You can own up. You know, perhaps it's motivation. Maybe going to the gym is on that part of your to-do list that you never get round to actually doing. Or maybe it's opportunity. You've just hit a very busy patch. The point is, it only takes one of those three things to stop you doing it. Capability is things like training, knowledge, tools, processes, that kind of thing. Motivation, I think, you know, hopefully we will all recognize the importance of motivation in anything we do. Opportunity, you know, I hear a lot of talk about not having the time to do what needs to be done. And, you know, this is a challenge in all our lives, isn't it? And but this is a problem for leaders. As leaders of change, we need to make the time. We need to make the opportunity for change to happen. And so it is with leaders of innovation. If we don't make the space, it won't happen. Okay, so we've looked at an innovation equation and a change equation, and now I want to try and complete the picture, build a picture by bringing these things together. And I want to do that by using a tool that I've called the 9 windows of innovation. This tool takes each variable from the innovation equation and combines it with a variable from the change equation. And like the equations, each window is vital to innovation generating benefit. So, you know, it doesn't matter how much capability we have to be creative if we don't have opportunity to share our knowledge and build our knowledge, then the benefit from our innovation will probably be low or zero. Now, we can use this tool in 2 ways. We can use it to look at our current innovation process. Use it to ask questions like, what is our capability to be creative? What is our motivation or our opportunity to share our knowledge around innovations and generate new knowledge? And the second way is that we can look at how we can improve each window. What is it that we can do to improve, you know, our capability to be good program managers? So, for example, you know, TRIS training, as we've seen, will improve your creative capability. But as Birdie Attell pointed out as well, that it also increases your motivation to be creative and to innovate. It also gives you access to the world's knowledge about how to come up with breakthrough solutions to problems. We do a lot of problem-solving workshops for clients, which is a great way of giving staff the motivation as well as the opportunity to be creative, but also share their knowledge around the problem and around the solutions. Becoming a learning organization, you know, introducing things like suggestion schemes and, you know, innovation portals, all this sort of thing, will increase your capability to share knowledge and stimulate discussion and debate in your organization. Partnering with other companies, but also you know, academics, is a great way of stimulating not only opportunity and motivation, but the capability to share knowledge and broaden your knowledge base. Many governments will fund collaborative research because they realize that breakthrough innovations often happen at the interface between knowledge domains. Creating roles, you know, with defined responsibilities for project and program management, even if they're not called program managers, you know, is a good way of creating the opportunity and motivation for project management to happen in your organization. And of course, providing project management training is really important. As a young engineer, I had some intensive project management training. And although I was never, you know, solely a project manager, it was very useful to me later on to help drive through the change that innovation demands. You need to be able to do that. So, in conclusion, I hope I've been able to paint a picture today of what innovation is, what the key ingredients are, how we put them together. Maybe helped you think differently about innovation, why it is hard, how we go about improving it, and maybe most important of all, what kind of questions to ask. At the beginning, I asked a question, you know, what is the one thing that you would improve about your innovation process if you could? Would your answer be different now? I hope you'll think about that over the next couple of days, and you know, when you've had all the input from from all the speakers. I'd like to close by coming back to learning, and this quote that I really like from Peter Senge. He says, in the long run, the only sustainable source of competitive advantage is your organization's ability to learn faster than the competition. I'd like to go a bit further and paraphrase him slightly by saying that in the long run, the only sustainable source of a competitive advantage is your organization's ability to innovate faster than the competition. So I hope these observations and tools and this conference will help you innovate faster. Thank you.
Thank you.